Alright guys, so we do the third revision sheet here. So the question we're going to do is the one on page 82. So we're going to do a bit here on polygons. So the question we're going to do is, the question from the book we're going to do is this page 82, question 2. So an incomplete design of kitchen weighing scales is shown below. The design is based on a regular octagon, 8 sides. Draw the scales to the dimensions given below. Complete the scales design by adding the following to your drawing: an appropriate container of your choice to sit on top of the scale, so I'll leave that up to you, and 12 dial markings spaced equally apart. Use 30/60 set square to divide up the circle. So I'll go through that there. Okay, so just stand this up here. Alright, so we've got an octagon, so I want you to put in this kind of formula here. So we've done it in class. So if I've got an octagon, that means I've got 8 sides. If I couldn't remember the angle at the bottom of an octagon, whether you can or can't, you can get out of it by dividing 360 degrees, so the number of degrees in the circle, divide 300, so I've got 5mm apart lines here, 360 degrees divided by the number of sides, which is 8, and that's equal to 45 degrees. Now, I know that. If you didn't know it, you can use a calculator. You can do it using division. Do your division up here to the side. There's no problem with that. But it's equal to 45 degrees. Now, and that is this is sometimes a waste of time to people. Knowing the 360 divided by, just see if I, knowing the 360 divided by 45 or divided by 8 or the number of sides is a waste of time to some people because they don't know what that 45 degrees means. The 45 degrees refers to the external angle. External angle. External angle. Okay, so the base of this is 50. So it's going to be 50, maybe 100. I come down 100, and I think I'd have enough there, and 150. Or no, we have to put in a container on top. So I come down 100 and there, down 170. So I can down 170, I'll draw my baseline along there, and then I can come in, I'll come in 50 from the side, and then I'll make my base 50 as well. So it'll be nicely over there to the left hand side. Okay. Right, so there is my base of 50. Up from there, up to there. There's my base 50. Now, 45 degrees refers to the external angle, which means it's not the angle inside in the polygon. Put in polygon in here. So it's not the angle inside in the polygon, it's the external angle. So it's the angle on the outside, external. Alright? So that 45 degrees refers to the angle on the outside. So if I extended the side next to it and got the angle to the side that is that I'm drawing, if I extended that and looked for the side, that angle would be 45 degrees. The external angle is 45 degrees. So I'll go 45 degrees that way, and 45 degrees the other way. You can do it with your protractor as well. It might take a little bit more time. Okay, so there's my my two sides. Going at 45 degrees, the size one, I'll use my compass to mark off the sides so that it's the same on all of them. So just to make doubly sure, I'll use my compass, so I'll mark the compass, and mark the compass like that. So that's 50 out either of them sides. Then 45 degrees, the external angle this time, 45 degrees is going to be there like that, which actually ends up being 45 plus 45 makes 90. So it goes straight up. So I extend that straight up. and I'll mark my 50 out there. And then we have two ways to finish this. We leave off the container just because I need to be putting a few bits underneath. So we're going 45 degrees again, external angle 45 degrees, external angle 45 degrees. And what I'm going to do, you can either mark them off here like that, mark it there and there, or you can project up the 50 you already have on the base here. You can project it straight up like that, and where it cuts through that line, and where it cuts through that line, gives you a horizontal line 50 apart, so it has to be the top of the yoke we're looking for. Alright, so finish off what I have. So there's my top, side, one side, there we go. So there's our octagon, okay? Right, we'll put this little fella on top. So you can see here the 50 is divided into 26, 12 and 12, which gives us 50. So if I come in, so there's my 50. So if I come in 12 from this side, okay, like that, and I come in 12 from the other side, like that. So it tells me to extend up. So remember a line, shortest distance from one point to another. I extend up this side and extend up this side. And it tells me that the line starts here and goes at 60 degrees until it hits that line. Starts here, goes at 60 degrees until it hits that line. So there's my 60 directions there. So there's my 60 degree set square. And I can draw that up until it hits that line. There we go. And I go 60 degrees the other way. And I draw that up. It hits the line there. Okay. Turn across, there like that. And there's the top of my flying scales. And all I've left to do now is draw the two radii in the centre. So to do that, I'll find halfway here. 25, and I'll just draw a vertical line because the middle is going to be up there. Right, so there's there. I'll do the same around here. Find 25 on this line here. Get halfway. Alternatively, I could join one diagonal to the other where the cross through would be the same. You could join all them like you're looking down top of an umbrella, and this the kind of bars in it are going into the middle, or that little spike part in the middle. So if you join all them, you get the middle as well. So there's the centre of it, and then I have to draw two circles from the same. So they are the same circles with the same centre. Circles with the same centre are called concentric circles. So they are circles with the same centre, but they can be getting bigger. So they can be different sizes, but they all have the same centre. So one of them is radius. One of them is radius 50. So 50 charged up my compass. There's 50 down the centre like that. And draw my circle around like that. And the other one has the same centre. It's concentric this time. It has a different radius, and that radius is 40. There's my Okay. So there is my scales. Okay, with so the dial is going to be in here in the middle, and they've already told me if I divide up that into 30/60, so if I get my set square, so this can be tough enough now. So if I get my set square, and basically what you do is you're going to divide. We're going to put numbers inside here, going all the way around. Is there a clock on it? Why does it 12? So I don't know. So maybe so they want us to divide this in the center up into 12. So they want us to divide this circle. How many degrees in a circle? 360. They want us to divide it into 12. So if we didn't know, 360 divided by 12 is 30. So that means if I do 30 degrees, 30 degrees, 30 degrees, 30 degrees, 12 of them will get me all the way back to the start. Now, a nice handy way to divide it up is your 30/60 degree set square. Alright, this is kind of something that you'll know when we start pushing on in orthographic projection and a few more, you'll be getting used to this. But 30/60, this is how you divide up a circle into 30/60. So you just get your set square and basically use all the sides. When all the sides are used up, turn it around and use all the sides there. So I'll show you what I mean. So I'll start with this side. Through the center, I'll go like that. I'll slide over this side. I'll go like that. And there's the two of them sides used. I'll turn it over. I'll use this side here. Make sure it's sitting on the T-square. This side is already used. Look, you can see there it's already divided up. So that one is fine. I'll turn it over this way. I'll use these sides. So I've got that one there. And all I've left, that one is already used. All I've left is the one going across the middle. And you can see here, it's like the spokes of a wheel. The spokes in the wheel of a bike. Look, it's all divided up nice and evenly using that 30. So 30, 60, 90, 120, 150, 180. So 180 is one straight down. 210, 240, 270, 300, 330, 360 back to the start. So there's 12 of them there. Alright. So what they want us to do is put little dials in there. I wouldn't put numbers because it is not a clock. They just want you to put in some sort of I mean you can put whatever dial markings you want. Look, just pretend it's a clock actually. I don't know what it's 12. Just pretend it's a clock. You can do whatever sort of don't necessarily have to be numbers. What I'm going to do is I'm going to pick a radius to give myself as a guide. So I'm going to go maybe to there, right? So this design, I'm going to put a little circle in there, right? Like that. And I'm going to put all my designs there, 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 there. And all the way around there, where that circle meets there. So I'll put, what should I do? Oh, you know a better job than me, but I'm going to put little circles on it. This monstrosity, isn't it? So maybe these circles are a bit big actually, lads. But look, you can do whatever kind of design you want, and then maybe I'd colour them in after. That's beauty about drawing with pencil, and so you'll be able to say them circles are a bit close together. But basically all I want you to do, I want you to do the same. I want you to divide that circle up into 12 using the lines, and I want you to do something at all them parts there. You can put numbers if you want. If you want to do 12, 1, 2, 3, if you want to do some sort of Sometimes clocks will they'll just do 12, 3, 6, 9, 12. So in between they might have dots or something. Maybe you could do the circles and put the number in the middle. You can do whatever you want. I'll leave it up to yourself, alright? But do something around them 12 points there. So you've got the same as you'd have on a clock. Right. Okay, after that, I want you to do something down here. So I want you to come up. Do over here. I want you to come up 20 from the bottom down here. Okay. Draw a line across to that. Okay. And I want you to come in 40 and then draw a base of 40. Like that. In 40, base of 40. And I want you to draw a pentagon. How many sides in a pentagon? What would you do here? I want you to draw me a pentagon with a base of 40 millimeters. So there's 40 millimeters there. Okay? And then after that, you can extend out the base of this. Extend over the base of that. All the way over to your keywords. And you're going to have to find out how you did this before. I want you to come in a distance of 100. Like that. From the line on the keywords. And then I want you to get 80 on your compass. Radius of 80. And draw me a circle of radius 80 in there. So a 2H circle, radius 80. And in that, I want you to put a hexagon that the corners of which touch the circumference. Right? So the biggest hexagon you can possibly put into that circle for me, please. Alright, so a pentagon, I'm giving you a base 40, I want you to draw me a pentagon with base 40, and in that circle of radius 80, I want you to put me in the biggest possible hexagon you can. Alright? Excellent.